Today we are going to speak about integration by partial fractions. So partial fractions is applicable only when you have the product of two functions in a certain way. For example, how to integral of 1 by x plus 1 into x plus 2 dx. Okay. In these type of integrations, we have to use by partial fractions. Okay. Now, in these partial fractions, we will assign some pre-assigned constants. So let I be this. Therefore, 1 upon x plus 1, x plus 2 be as a upon x plus 1 plus b upon x plus 2. What is a and b? A and b are the constants we have to find out. Okay. Once we have a constants, then we can integrate separately and we'll get answer. It means integral 1 by 1 upon x plus 1 into x plus 2, we can break into the sum of fractions, and then we can integrate differently. Okay. Now I am considering this integral as 1 upon x plus 1 into x plus 2 by assigning some arbitrary constants a and b. A and b are the constants we have to find out. Okay. Now in order to find out these constants, let's multiply x plus 1 and x plus 2 on both sides of this equation. So let's call this equation as equation number 1. Now I will multiply x plus 1 and x plus 2 on both sides of this equation. Okay. Now if I multiply x plus 1 into x plus 2 in this equation, so I will be getting what? X plus 1, x plus 2 upon x plus 1, x plus 2. I am multiplying x plus 1 and x plus 2 on both sides. On both sides for each terms. Okay. Is equals to a into, now this term I am multiplying on both sides. So x plus 1 and x plus 1 will get cancelled. I will be getting what? X plus 2 means x plus 1 and this x plus 1 will get cancelled, plus b upon, and then what? X and another will be x plus 1. Let me repeat again. I am multiplying x plus 1 and x plus 2 on both sides of these equations. Okay. Now if I bring this whole term, okay, if I bring this whole term over here, now in down I have x plus 1, in up I have x plus 1 into x plus 2. So x plus 1 and this x plus 1 will get cancelled. So I have x plus 2. Okay. Now this whole term I am bringing over here, then x plus 2 and x plus 2 will get cancelled. So x plus 1 will be there. Okay. Now same term will get cancelled. So we have 1 is equals to a upon x plus 2 plus b upon x plus 1. B upon x plus 1. Now think. Now our aim is what? To find a and b, these arbitrary constants a and b. Now we have to substitute something, values of x, where we can get the constants are a and b. So let's think about what I have to put in this equation. What if I put x equals to something, some term will get absorbed or some term will get cancelled, and I'll be getting some pre-assigned, or you can say constants of a or b. For example, if I assign, since x plus 2 is over here, now if I put x equals to what? Minus 2. Let's see. Okay. Now if I put x plus 2 in this equation, okay. Now x plus 2 in this equation, what? Minus 2 plus 1, what? Minus 2 plus 1 is 0. Now something by 0 is 0. Now what? I will be getting the value of b, right? Similarly, if I put over here x equals to minus 1, so b will be, this term will be 0. So I will be getting the value of a. Okay. Therefore, putting x equals to minus 2 in this equation. Why minus 2? Why not other number? Say, if I put x equals to say for example 4. If I put x equals to 4, you what? X plus 4 plus 2 is what? 6. This term a will be as it is. Similarly, b will be there as it is also. There will not be any effects. Therefore, I am putting x equals to minus 2. This implies 1 equals to, now a upon minus 2 plus 2 is 0. Now b upon minus 2 plus 1 is implies 1 equals to b upon minus 2 plus 1 is minus 1. Therefore, I am getting b equals to minus 1. Okay. Now, if I put x equals to minus 1 over here, then I will be getting the value of what? A. Okay. Similarly, if I put x equals to minus 1 in this equation, 1 equals to, we have right for left hand side 1. So 1 equals to what? A upon minus 1. Sorry. When x equals to minus 1 plus 2 is implies 1 equals to a upon what? Minus 1 plus 2 is 1. Is implies a equals to 1. So by assigning the values of x some certain number, we are getting values of a and b. These are constants. Okay. Now the substituting the values of a and b in equation number 1. Okay. Let's say over here, putting the value of a and b in equation 1. Okay. Therefore, this integral will be what? A means what? 1. B means what? Minus 1. Okay. Therefore, integral of 1 upon x plus 1 into x plus 2 dx will be same as what? Same as a means what? A is 1. Okay. 1 upon what? X plus 1. 1 upon x plus 1. Since I assigned integral left hand side, so I will be writing integral everywhere. Okay. So b is what? B is what? Minus 1. Okay. Plus or minus will be minus integral of dx of what? X plus 2. X plus 2. You can consider 1 is there. A means 1. I don't have to write anything. Therefore, I am neglecting dx upon x plus 1. Similarly, minus. Why minus? Because b is over here minus. So, I am substituting this value over here. So, minus of 1 upon x plus 2. Okay. Now, in integration, we have some formulas. Okay. Like integral of, now if you are differentiating this, if you are getting this, okay, we have denominator and numerator, so that is log of this one. Now let's say, for example, if you are differentiation of x plus 1 is what? 1. Okay, differentiation of this one, I am getting this, therefore this is log of x plus 1 minus, similarly differentiation of x plus 1 and x plus 2 is one and same. Say d by dx of x plus 1 is what? Differentiation of x plus 1 is d by dx of x plus d by dx of 1. Okay, d by dx of x is what? 1. And differentiation of any constant is what? 0. Okay, this is 1. Similarly, let's check over here, d by dx of x plus 2 is what? D by dx of x plus d by dx of 2. Okay, d by dx of x plus d by dx of 2. So d by dx of x is what? 1. 1 plus 0 is equals to 1. Same. Therefore, this is log of x plus 1 and minus log of x plus 2 plus some constant. Okay, plus some constant. You can keep as it is, or by using logarithm formula, log m minus m is same as log m by n. Okay, this is same as log of x plus 1 upon x plus 2 plus c. By reason is log of m upon n is same as log of m what? Minus log of n. Okay, this is the answer.